Okay, so for the first one here, we're coming back, don't worry. Sine of 80 degrees equals A. All we have to do is type in sine of 80, making sure we're in degree mode, we get 0.9848. Tangent of 20 equals B. Again, we just have to hit tangent in 20, 0.3640. Yeah, it's 397. How many have the first two right so far? Okay. Number 3 is where it gets tricky. Cosecant uses sine. So it's sine of 50, then x negative 1. Yes, 1.3054. Cosine of 10 degrees. Well, that's just the cosine in 10. 9848, you got it. Cotangent of 30 degrees uses which function? It uses the tangent of 30 and the 1 over x, which gives us 1.732. And secant of 40. Secant uses cosine of 40. That sounds about right. 1.3054 is correct. Now, up here, before we start, can anybody tell me which two of these are impossible? 10 and 12. Sine is always between -1 and +1. So we can't have a 2.3. Cosecant, actually secant and cosecant are always either larger than 1 or smaller than -1. So they can't be between -1 and 1. So that one cannot be done either. So number 7, cosine of g, of course, that's just second cosine, 0.84. Why are we using the second cosine, that cosine -1, instead of just cosine? Yeah, we're given the value of the function and we're trying to find the angle, so we're going backwards, which gives us 32.86 degrees. Cotangent, we have to use tangent, so we're going to use that inverse tangent, 3.1, and the x -1 goes inside the parentheses for that one. So it's second tangent, 3.1, x -1, then close the parentheses, 17.88 degrees. Secant uses cosine, so do second cosine, 4.5, x -1, second cosine, 4.5, x -1, and close. 77.16 degrees. We can't do the sine because that was not a possible value for sine. Tangent of k, we're just going to do inverse tangent. Second tangent of 0.84, 40.03 degrees. Remember, tangent and cotangent can take on pretty much any value, but the only value they can't take on is 0. What do y'all think? Remember, this all comes from this unit circle. Where this is our angle. And remember, a sine is the distance from a point on the circle to that reference diameter. So that distance right there is the sine of that angle. Tangent is tangent to the circle at that reference diameter, and it goes until it intersects that terminal side. So the length of that is the tangent of that angle. The length that we have to extend that terminal side out to intersect the tangent is the secant of that angle. And remember, those are the three main trig functions: sine, tangent, and secant. Even though we use cosine because on the calculator rather than secant. Where does the cosine come into this? Remember that prefix co means of the complement. Cosine means the sine of the complement. So cosine of theta would be the sine of the complement of theta. Well, this here is the complement of theta because this is 90 degrees here, right? So since that's the complement, the cosine is this sine right here. That would be the cosine of theta. We usually take it down here just because that forms a rectangle because they're all right angles. We usually take this down here to be the cosine of theta. Oops. As we continue on, cotangent, we're using the vertical axis now as our reference axis. The cotangent is the tangent off the vertical axis. And the cosecant is then that distance where it meets the cotangent. Yeah, the secant meets the tangent, the cosecant meets the cotangent. So what you can tell here, there's a lot you can tell about our angles just by looking at this. If the angle theta let's just do this, goes from 0 degrees to 90 degrees. So it's starting at 0 and moving up to 90. What happens to the sine? Gets larger. What happens to the cosine? Gets smaller. What happens to the tangent? Tangent's going to get larger. Where the tangent is this piece right here, it's going to get big, longer and longer up here the bigger that angle gets. It actually gets up to infinitely long at 90 degrees. So at 90 degrees, the tangent isn't defined because we can't have something infinitely long. Yes, at 89.999, it's going to go a long, long ways out there before they intersect, but it will intersect eventually. So that tangent's going to be, way up here before it intersects, but it will intersect eventually because there's still some angle on that. They're not quite, at 90 degrees, they become parallel and they never intersect. Now, looking at the cofunctions, what happens to the cotangent? As that angle gets bigger, is that cotangent going to get shorter or longer? It's definitely going to get shorter, so the cotangent gets smaller. What happens to the cosecant? It's going to get smaller as well. How about the regular secant? Well, as the tangent gets longer up here, the secant has to reach out further to get to it, doesn't it? So it gets larger. So as our angle goes from 0 to 90, sine, tangent, and secant all get larger. Those are the main functions. The cofunctions, you can see cosine, cotangent, cosecant all get smaller because the complementary angle is getting smaller. So if theta is between 0 degrees and 45 degrees, which is larger? Secant of theta or cosecant of theta? Cosecant. Because if the angle itself is between 0 and 45, that means the complement's bigger than the angle, right? So the complement will be bigger. Cotangent or tangent, the complement's still bigger, right? Sine or cosine, complement is still bigger. If this angle here is between 0 and 45 degrees, in other words, less than 45 degrees, let's say that's like 44 degrees even, the complement here is bigger, it's 46 degrees. So all the complementary functions will be bigger. There you go. If theta is between 45 degrees and 90 degrees, then which is bigger? Sine theta or cosine theta? Sine, you got it. Secant theta or cosecant theta? Secant. Cotangent theta or tangent theta? Tangent, good. That's the angle is bigger than its complement, so those regular functions are bigger. It's hard to get that out, get it out of your head that the cosine is one of the main functions because it's one of the buttons on your calculator. But it isn't. It is one of the cofunctions. What's that? It's got it right in there, cosine, yes. So between 0 and 90 degrees. First of all, at 0 degrees, what's the sine of that 0 degrees? It is 0. What's the cosine of 0 degrees? 1. It can never be bigger than 1. Remember, cosine is this distance here. At 0 degrees, that's just your whole radius. Tangent of 0 degrees. 0. If this is the terminal side here, that tangent doesn't go up at all. Secant of 0 degrees. 1. 1 over cosine. 1 over 1 is just 1. Cosecant is 0 degrees. Why would it be undefined? Well, it's 1 over sine, right? What's 1 over 0? Punch out your calculator gives you a naughty message, right? Can't do it. Cotangent of 0 degrees. Undefined. Tangent is 0, right? Cotangent is 1 over tangent. 1 over 0, again, undefined. But up here between 0 and 90 degrees, the sine of the angle is positive or negative? Positive. It's going to be somewhere in here. It's going to be above the axis. It's going to be positive. Cosine of theta. It's positive. Cosine theta goes in this way, that's the positive side of 0. If both sine and cosine are positive, everything else has to be positive. Secant has to be positive because that's 1 over cosine. Cosecant is positive because that's 1 over sine. Tangent can actually be calculated as doing sine over cosine, which we'll look at in a little bit. So tangent has to be positive. And cotangent has to be positive. How about at 90 degrees? Well, at 90 degrees, sine is what? 1, right? What's cosine of 90? 0. The distance, if the terminal side is at 90 there, right? The distance to the side is 0. Tangent of 90 degrees is undefined because that would keep going forever. This would keep going forever. They're parallel, so it doesn't ever intersect. Cotangent of 90 is 0. Secant of 90. Well, secant goes off of cosine, right? 1 over 0 is undefined. Cosecant of 90 is 0. You got it. Actually, no, sorry, not 0. 1. 1 over sine, which is 1 over 1. Over here then, between 90 degrees and 180 degrees. Sine of theta is still above 0, right? Well, sine is vertical. That's positive. Cosine, however, is negative because that's the negative direction, right? And that's cosine. So if sine is positive and cosine is negative, tangent has to be, what's a positive divided by negative? Negative. Cotangent then has to be 1 over a negative. It's going to be a negative. Secant has to be negative because it goes off the cosine. Cosecant is positive because it goes off the sine. At 180 degrees, sine of 180 degrees is, your vertical distance would be nothing, right? Cosine of 180 degrees would be negative 1. Tangent of 180 degrees is 0. 0 over negative 1 is 0. Cotangent, however, undefined. Secant is 1 over cosine. What's 1 over negative 1? Negative 1. And cosecant. Cosecant is 1 over sine. Sine is 0, so 1 over 0 is undefined. Between 180 degrees and 270. Sine is negative. Cosine is negative. That's also in the negative direction. Tangent would be, negative divided by sine divided by cosine. Negative divided by negative is a positive. Cotangent 1 over tangent, 1 over a positive is a positive. Secant, 1 over cosine, 1 over a negative is a negative. Cosecant, 1 over sine, sine's negative, cosecant's negative. At 270 degrees, sine of 270 degrees is, more specifically, -1. Right? Cosine of 270 degrees, 0. Tangent is undefined. Because there is sine over cosine, -1 over 0 is undefined. Cotangent is just 0. Secant, that's undefined because it's 1 over cosine and cosine is 0. Cosecant, 1 over sine, 1 over -1 is just -1. Between 270 and 360, or n 0, whichever way you want to put it. 360 and 0 are the same spot. Sine theta is negative, still below the axis. Cosine, however, is positive. That's back in the positive direction, which means the tangent is negative. Cotangent, negative. Secant, 1 over cosine, cosine's positive, so secant's positive. And cosecant would be negative, 1 over sine. That's a helpful little chart to keep in touch with as we go through this. Just that whole circle itself. I mean, you don't have to necessarily memorize these positives and negatives, but if you understand how the circle works, this unit circle thing here is just incredibly powerful for dealing with the trig function values. Now, of course, we did relate those to the sides of a right triangle. So if this is my triangle, I'm going to label my angles A, B, and C. Now, the sides of a triangle get labeled according to the opposite angle. So this bottom side down here is opposite angle A, so it gets labeled side little a. Always use a capital letter for the angles, a little letter, small letter for the sides. So what's this side over here? Little b, and this side is little c. So the right angle is typically labeled angle C, so the side C would be the hypotenuse. So, which side is the hypotenuse? C. I kind of gave that one away, didn't I? So the hypotenuse is side C. Which side is the adjacent side? There you go, trick question. The adjacent side and the opposite side depend on which angle we're looking at. So I'm going to adjust colors here. If I am looking at this angle here, which side is the adjacent side? Little b is adjacent. Remember, adjacent and opposite are always legs. The opposite leg would then be little a. However, if I were looking at this angle here, which side is the adjacent leg? Little a. And the opposite leg? Little b. So it depends on which angle we are looking at. So let's give you some sides here. If I ask you for the cosine of angle A, cosine is adjacent over hypotenuse. What's the adjacent side? Angle A is right here, isn't it? Adjacent is the 6. Hypotenuse is 10. If I ask you for the sine of angle B, remember sine is opposite over hypotenuse. Well, this is angle B. What would be the opposite leg from B? 6, and the hypotenuse is still 10. Always 10. Well, the hypotenuse never changes, put it that way. Notice the sine of B and the cosine of A are the same because A and B are complements. Tangent of A. Tangent is opposite over adjacent. Very good. According to angle A up here, what's the opposite side? 8. The adjacent side is 6. 8 over 6, or 1.33333. Secant of B. Remember, secant is hypotenuse over adjacent. Then this one, that'll be 10 over, for angle B, what's the adjacent leg? 8. Note, secant and cosine, they are reciprocals, aren't they? Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. That's why we just did 1 over cosine. Cosecant of B. Cosecant is hypotenuse over opposite. So that'd be 10 over, this is angle B, the opposite is 6. Again, note, sine and cosecant. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. They're reciprocals. Well, we're on the topic. Tangent is opposite over adjacent. If I look at sine over cosine, sine is opposite over hypotenuse, correct? Cosine is adjacent over hypotenuse, correct? If I do the calculation and I divide this out, opposite over hypotenuse, which is the sine, divided by cosine means we multiply by the reciprocal, which is hypotenuse over adjacent. You'll notice the hypotenuse cross cancels out, we get opposite over adjacent, which is the tangent. So up here, I have the cosine of A. What is the sine of angle A? Sine of A would be opposite over hypotenuse, 8 over 10. So cosine of A is 6 over 10. Sine of A is 8 over 10. If I were looking for the tangent of A, I could just do sine over cosine, right? So that's, 8 over 10 times 10 over 6, which is 8 over 6, which was tangent. If I tell you that sine of theta is 0.866, and tangent to theta is 1.732. Can you find all those other functions? Sure we can. Cosine can be found using that equation, right? That equality. We know the tangent is 1.732. We know the sine is 0.866. We are looking for the cosine. We can just make this a 1, and it's 1 times 0.866 divided by 1.732, which is 0.5. Cosine is 0.5. Can we find cotangent? Yeah, it's 1 over tangent, which is 1 over 1.732, or 0.577. Can we find secant? Well, secant's 1 over cosine, which is 1 over 0.5, which is 2. How about cosecant? Yeah, it's 1 over sine, which is 1 over 0.866, which is 1.15. Bless you. We're going to go over this part again. There's a reason I show it to you today, because I don't expect you to remember it today, but you're going to see it 2 or 3 more times before I expect you to remember it. For today, out of your happy packet, page 345 to 347, there's a set of problems there to do. Have fun with them.